Okay, so this question is asking to find a domain which these two functions here are one-to-one, and find a formula of their inverse on that domain. So all a one-to-one function is a function that has an inverse. Um, you can have a function that isn't one-to-one, and it's still a function, but if it's not one-to-one, it won't have an inverse. So you can find, there's two ways, well, there's at least two ways to find if a function has an inverse. One is graphically, which I'll show you, and then you can also do it algebraically. So the way you would do it algebraically is to prove that there's only one unique output for an input. So you can't input two different numbers and have those two different numbers be mapped to the same output. If that's the case, then it's not one-to-one. So you can make the assumption that that f of x equals f of y. So this is just assuming that some x is going to give you some unique output y. So you would just plug this in to our function here. That would give you 1 over x plus 1 equals 1 over y plus 1. That's going to give you y plus 1 equals x plus 1. And then these ones are going to cancel, and you're going to be left over with y equals x. And that's what you wanted to find. That means that this function is one-to-one. Now the only thing you would have to consider is that when x is equal to negative 1, you're going to get 0 in the denominator, so the function's undefined. At negative 1. Now in order to find its inverse, you just swap your x's and y's and then solve again for y. So that would be like, well, you would have y equals 1 over x plus 1. That's your function. Now just switch your x and y. So you have x equals 1 over y plus 1. And now solve for y. That's going to give you x, y plus 1 quantity is equal to 1, y plus 1 equals 1 over x, and finally y equals 1 over x minus 1. And this is the formula, or the equation of your inverse function. You could also notationally express this as f inverse of x is equal to this stuff here. Okay, that's how you would do it algebraically. Let me show you a graphical representation of this. So here's f of x equals 1 over x plus 1. You have the horizontal line test. You know how you have a vertical line test to prove whether or not if it's a function, you can use the horizontal line test to test for one-to-one. And basically, if you can draw a horizontal line, and if that horizontal line intersects the graph at 2 spots or more, then your function is not one-to-one. So as you can see here, it only touches at one point, so your function is one-to-one. Of course, it's just undefined here at x equals negative 1. Okay, so for the second one, f of s equals 1 over s squared. So do the same trick. You can, it doesn't matter what variable you use. I'm just going to stick with x and y. Fill in your variables then to this function. You get 1 over x squared equals 1 over y squared. And then that's going to give you y squared equals equals x squared. Take the square root of both sides. And remember, when you take the square root, you're going to get back a positive and negative value, because you could square a negative number or a positive number and it's going to map you to the same. Negative 2 squared is 4. 2 squared is 4. So here you're going to get y is equal to plus or minus x, but you're also going to get x is equal to plus or minus y. And because of this, you know that your function as a whole is not one-to-one. But it can be one-to-one over a restricted domain, and that's what this problem is asking you to figure out. Oh, let me go back to the first one. So, find the domain. So, the domain D would be negative infinity to negative 1, union negative 1, positive infinity. Now, for the second one, I guess what you would have to do here is go look at a graph. So you either graph the function in your calculator or use Wolfram like I did. You can see the graph here. Fails the horizontal line test. You have one y value that you can arrive at from two different x values. But if you restrict the domain, you can tell that these are approaching 0 from both sides, because here we're undefined at 0. If you restrict the domain to only be this side or only be this side, you'll have a one-to-one function. So your domains are, where it's one-to-one would be negative infinity to 0, and then also you would have another domain that would be 0 to positive infinity. Okay, now as far as getting an inverse, do the same thing. You can use any variable. Here we have s, well, let's call that t. Let's just say t is equal to 1 over s squared. Switch your variables. S is equal to 1 over t squared. Then you have s t squared equals 1. T squared equals 1 over s. And t is equal to the square root 1 over s. And again, since we started out with this, we can express the inverse as f inverse of s equals square root 1 over s. Okay, last problem. This one's fairly straightforward. They're asking you to solve this without using a calculator. One thing that's good to know, if you don't already know about functions and their inverses, is that they undo each other. It's kind of like you apply a function to something and it's going to wrap it up in a box. If you apply its inverse, it's going to undo that box, and you're left with whatever was originally in that box. So arcsine, that's the same thing as sine to the negative 1. I just like this notation better because it's not as misleading. This negative 1, it's not an exponent. It's a notation used for the inverse, but some people treat it like an exponent, and it's 1 over sine, which this is not the case. It's just confusing. So I like arcsine, arctan, arccos. So as far as the undoing goes, you can just take this arcsine of 1/2 is equal to some number x, apply its inverse to both sides, and when you do that, you're going to undo this, and you're just left with the 1/2. So you have 1/2 equals sine of x. And then you can just look at a unit circle, and you know sine is 1/2 at pi over 6, and then also 5 pi over 6. But the reason I threw this graph up here, you can see that arcsine is only over the range negative pi halves to positive pi halves. So that's only this side of your unit circle. 5/6 is over here. So that means your answer is only going to be this one. Alright. Hope that helped.